सो चैप्टर नंबर 2 आज हमारा टॉपिक है पोटेंशियल डिफरेंस एंड पोटेंशियल at a point. We already know that work done between 2 points in an electric field due to some arbitrary charge R to P was equal to minus integral E dot d R to P. Here Q. ठीक है. Now we here see that work done is proportional to charge. Now if we have some charge Q at origin of the coordinate axis, Z axis, then it will produce an electric field. Then the work done at any point in the field will be proportional to charge. Now, in order to make this a quantity which is independent of the charge, place it at that point. We define another quantity, that is work done per unit charge, which is equal to minus integral E dot dr, let us say R to P. This quantity work done per unit charge is called potential difference between 2 points in an electric field. Now, we already know that work done is equal to potential at P minus potential at R. If we divide this thing by Q, then taking this right hand side, we can write here UP divided by Q minus UR divided by Q is equal to minus integral E dot dr. The quantity this is called potential at point P due to discharge Q. This is independent of charge. Furthermore, UR is potential at point R. Let us say this is point R in electric field of Q. So we write this as Vp minus VR equal to minus integral E dot dr, or simply is equal to over by charge. So the potential, this is potential at P, this is potential at R. This point here it is Vp and VR, and here it is Vp. तो दो जगह पे ये potential है. Now the thing which we are interested is the potential difference, Vp minus VR. So how can we define? Now when we bring, let us say we have a unit charge here, 1 coulomb. We want to bring it to this point. Now work is to be done in order to move against the electrical forces. We bring this charge slowly so that there is no acceleration, slowly and reach the P. That the total work done in moving R to P is called as a potential difference between between point P and point R in electric field. Now, since potential is independent of charge, so this is a characteristics of that point. So whatever may be the here the point Vp, since this is independent of charge, that means it's the characteristics of that point. Here VR is the characteristic of the point R. So this is unique point. This is unique point. So every point has a potential difference which is unique at that point. So it is a characteristic of that point. Okay, now we can write Vp minus Vr is equal to work done in bringing a unit charge from R to P, this, okay, divided by this. Now definition: the potential difference, here by writing potential difference we mean electrical potential difference. The potential difference between 2 points in an electric field is defined as the amount of work done in bringing a unit positive charge without acceleration one point to another point against the electrical forces. Now, since work is a scalar quantity and charge Q is also a scalar quantity, therefore potential difference Vp minus Vr, which we can write as dV, is also a scalar quantity. Now, before defining units, we will first of all define potential at a point. Now, Vp, if R tends to infinity, then potential at infinity is taken to be 0, because we know that electric field E at infinity is equal to 0, which means that force QE is also equal to 0. Force acting on this is equal to 0. Therefore, work done F dot dr is also equal to 0, which implies that potential difference or potential is delta V or V is 0. Now, potential at a point. Potential at a point in an electric field is defined as the amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. Remember, acceleration is 0. We do not accelerate the charge while bringing it from infinity to a given point. Now we already know that V P minus VR is equal to VW R P by Q. Now R tends to infinity, then Vp minus V infinity is equal to V infinity W infinity to P by Q, or this is equal to Vp since V infinity is equal to 0, which implies that Vp is equal to, we can write simply as work by charge. So potential is work done per unit charge. So we have already discussed that potential difference is a scalar quantity, so is the potential at a point as scalar quantity. Now units. Unit of potential or potential difference is this work का है तो है joule per coulomb. Now joule per coulomb is called volt. The potential, let us define 1 volt now. The potential at a point is said to be 1 volt. If 1 joule of work is done in bringing a unit charge from infinity to the given point, in the electric, therefore 1 volt is equal to 1 joule or 1 coulomb. That is 1 V is equal to 1 joule per 1 coulomb. Now dimensions of potential is equal to dimensions of work divided by dimensions of charge, which is equal dimensions of work are M1 L2 T minus 2 divided by dimension of charge AT. So this will come out to be M1 L2 minus 2 minus 1 T minus 3 A minus 1. Okay. Now now we have another topic. Minus VR is equal to minus V2 or V